Hi all. We are coming to the last section of chapters potential and capacitor. Today we need to discuss about energy stored in a capacitor. See, you have a capacitor and you connect it with a battery. What happens? The capacitor will be charged. The capacitor will be charged. How much it will be charged? That's the main question to think out. Or what is the work? How this charging happens and what happened to that work? Or what is that work which make the capacitor to get charged? All those are the questions. Suppose it is charging to a potential V and C be the capacity of it. V is the final potential and C is the capacity and Q is the final charge it is going to store. Now let's take an intermediate point where the potential be V dash. Okay. Let's take an intermediate point where the potential is V dash. And when it is V dash, when the potential difference is V dash, we are giving a charge dq to it. dq to the cell. Sorry, dq to the capacitor. So the work done by the cell to give an additional charge dq at a potential when it is at V dash is given by dw equal to V dash dq. Now what is V dash? V dash will be Q dash by C. What is that Q dash? Q dash is the charge when it is at potential V dash. So Q dash by C, V dash. So dw will be equal to Q dash by C dq. And you can add so small works and you will get the total work. So you have to integrate it. You are charging starting from 0 and it will finally reach to Q. It will be Q dash by C dq. What happens to that? Work is equal to 1 by C is a constant. Q dash dq dash or Q dash dq will be, or Q dash, let it be dq dash. Okay. So Q dash dq dash is equal to Q dash square by 2 and it's starting from 0 to Q. Okay, instead of dq, I'm taking dq dash. That's all. How is that expression? See, why? Because integral x dx is equal to x square by 2. Okay, that's it. So it is Q dash dq dash is equal to Q dash square by 2, 0 to Q. So it will be 1 by C Q square by 2 minus 0 square by 2. Upper limit minus lower limit. So it is Q square by 2C. This much is the total work done. Work done in storing the capacitor or in charging the capacitor. And this work will be stored as the potential energy. This work will be stored as the potential energy. So U will be equal to Q square by 2C. U will be equal to Q square by 2C. See, you can have different form of equation for it. Why? Q is equal to CV, right? So it will be C square V square by 2C. So that will be half CV square. This is one another form. And also U equal to half CV into V. You can split it like this. That will be equal to half CV is Q, half QV. So U equal to Q square by 2C. U equal to half CV square. U equal to half QV. All those are the different types. Actually, the total work done by the battery is QV only, that you have to understand. Why? Because in order to move Q charge for a potential difference of V volt, the work required is QV. So the total work done by the battery is QV. But only half QV part of the energy is stored by the capacitor. Now, what will happen to that energy, or where that energy resides? It's a very interesting thing to be understood. I told you for a capacitor there are space between the plates. See, there is a positive plate and a negative plate. And the energy will be stored within the space of it, within this space. What is the volume of that space? What is the volume of that space? That volume is equal to A into D. Isn't it? A into D. And do you remember the electric field was equal to V by D? V by D. Electric field was equal to V by D. These all things we studied in the previous class. So this energy will be residing within the space of the between the plates of the capacitors. It will be residing within the space between the plates of the capacitors. What much? The energy stored will be U equal to half C V squared. This much energy. Now here we say there is a term known as energy density. Energy density. Energy density means energy by volume. Or we can bit more correctly say it is the energy stored per unit volume. Energy density is also known as the energy stored per unit volume. The potential energy stored per unit volume, we call it as energy density. So this will be half C V square divided by AD. Now let's do some operations on it. So for a parallel plate capacitor, it will be half C is A epsilon 0 by D, half V square by A D, right? So you can cut this AA and it will be half epsilon 0 V square by D square, or that is half epsilon 0 V by D the whole square, that is half epsilon 0 E square. This is energy density, U bar, or energy per unit volume. It's otherwise known as energy density or energy stored per unit volume. I will repeat one thing. The total work by battery is QV only, while the energy stored is only half QV. That you have to understand very well. Okay? That's about the first thing here. Energy stored in a capacitor. Thank you.